Hello, today I'm going to show you how to do the product rule in differentiation. We're going to talk about the form that this rule takes and 3 practice examples. So the form it takes, when you take the derivative of 2 functions multiplied together, you cannot take the derivative of the first function, the derivative of the second function, and multiply them together. You have to instead combine the two together using a special form. So the derivative of 2 functions multiplied together, denoted u and v, will equal the derivative of the first function times the normal second function plus the derivative of the second function times the normal first function. As an example, x cos x. Here we have 2 functions, x and cos x. We will denote u as x, v as cos x. The derivative of x is 1. The derivative of u is u prime equals 1. The derivative of cos x is negative sine x. Combine them together according to the formula in 1, and we get the derivative of x cos x is 1, which in this case is u prime, times cos x, which in this case is v, plus negative sine x times x, respectively v prime times u. Going on to the second example, here we have the derivative of x ln x cos x. It is 3 different functions. You will have to take the product rule twice. If we combine it into 2 parts off the bat, we'll have one function we'll say is x ln x, or one part we'll say is x ln x. The other part we'll say is cos x. So cos x will equal v, x ln x is u. Then you take the derivative of each. The derivative of cos x is negative sine x. However, the derivative of u prime, this is going to require another product rule. So we will split up x ln x, where x will equal s. I've used s and k in this part to avoid confusion with the u and v. Splitting up the x ln x, we'll have s equals x, k equals ln x. Take the derivative of each, combine them according to this formula, where sk prime is equal to u prime, and then we will get u prime equals 1, which is s prime, times ln x, which is k, plus x over x, respectively, which is 1 over x times x, or k prime times s. So now we have an answer for u prime after doing product rule once. We now have u, v, u prime, and v prime. Combining that in the product rule again, we have altogether the derivative of x ln x cos x is u prime times v plus v prime times u with their respective functions listed above. In the last example, we have x squared divided by sine x. Now, this is division, so it might seem better to use the quotient rule, but you can also use the product rule. After all, x squared divided by sine x could be written as x squared times 1 over sine x. This can equal x squared cosecant x, but if you don't know what the derivative of cosecant x is, then we can go to x squared times 1 over sine x being x squared times sine x, where the sine x is to the negative 1. In this case, again applying u and v to the different parts of this total function, where u equals x squared, v equals sine x to the negative 1, taking their derivatives, and then again combining it according to the formula, you will get this answer. And these are the two pages.